Below is a kite. Solve for missing information and find the area. Okay, so we have a kite, and since we know that it has diagonals, if we can find those diagonals, we can use the formula area equals 1/2 diagonal 1 times diagonal 2. Remember that a diagonal connects non-adjacent vertices. So these two green lines are my diagonals, but they're not labeled. So what I'm going to do is I'm going to think of them as sides of right triangles. If you have an angle and a side of a right triangle, you can use trigonometry to find unknown lengths. I'm going to start by solving for x. I'm going to use the sine ratio because sine is opposite over hypotenuse. And I know that x is opposite of my 40-degree angle and 10 is the hypotenuse of this right triangle. So sine of 40 degrees equals x over 10. In class, if we had x in a fraction, I just told you all to make the other side a fraction by putting it under or over 1 and then cross multiplying. So you get 10 times the sine of 40 degrees equals 1 times x. Since x is all alone, you can just type that in the calculator in degree mode and you get 6.4278. So about 6.43. In a kite, it is symmetric. So the other side part will be 6.43. So that entire diagonal will be 6.43 plus 6.43, which is 12.86. Now I need to find the other diagonal. So if I solve for y using either Pythagorean theorem or trigonometry, I can use the cosine formula. So cosine of 40 degrees equals the adjacent, which is y, over the hypotenuse, which is 10. Again, put it over 1 because you have your variable in a fraction. Cross multiply, you get 10 times the cosine of 40 degrees equals y, because 1 times y is y. And since y is all alone, just type it in your calculator, and you get about 7.66. But that's not the entire diagonal. So we need the bottom part of that vertical line. And so I'm going to shift my mind to look at this bottom right triangle. I don't have any angles, so I can't use trigonometry, but I can use Pythagorean theorem. Because if you know two sides of a right triangle, you can find the third side by using a squared plus b squared equals c squared. Where c is the hypotenuse, in this case 25, because it's across the right angle. Squaring 6.43 and 25, we get 41.34 plus z squared equals 625. Subtract 41.34 from both sides, you get z squared equals 583.66. And then you take the square root, you get about 24.16. The entire diagonal is 7.66 plus 24.16, which is about 31.82. So my area of my kite is 1/2 diagonal 1 times diagonal 2, 1/2 12.86 times 31.82. So you get about 204.60 square units, in this case square inches. I could have broken this one up into a bunch of triangles, found the areas, and added them together. On Khan Academy, I can break this shape up into a rectangle, a triangle, another rectangle, and another triangle. But first I need to label everything. Since I know the left side is 3.5, the right side will also be 3.5. Since the horizontal is 9, if I take away 2 and take away 5, I know that missing horizontal is 2 because all of those numbers have to add up to be 9. So the area of a rectangle is base times height. My base is 9, my height is 3.5 because they form 90-degree angles with each other. So the area of this orange rectangle is 31.5. This red triangle has a base and a height of 2. The formula for area of a triangle is 1/2 base times height. So 1/2, 2 times 2, which is just 2. This green rectangle, which happens to be a square, is again area equals base times height. So area equals 2 times 2, which is 4. This blue triangle has a base of 5 and a height of 2 because they form 90-degree angles with each other. So the area of a triangle is 1/2 base times height, 1/2 5 times 2, which is just 5. My entire area of this shape is when I add all 4 of these up, what a composite area is, you get 42.5 units squared. Here's another quick example. You can break this up into whatever shapes you see. I first see a rectangle and a trapezoid. A rectangle is area equals base times height, so 6 times 6, which is 36. And on the bottom, a trapezoid is base 1 plus base 2 times height divided by 2. Again, the two bases on a trapezoid are the ones that look like they're parallel to each other. So the longer base is 6 because it's the same as the 6 on the red square, and the other base is 3. The height on the trapezoid is not 13. It's whatever is left over when I take 6 away from 13. So the height is 7, because 13 minus 6 is 7. Plug everything in, and you get 9 times 7, which is 63, divided by 2, is 31.5. So the composite area is when you add these two shapes up. So 36 plus 31.5 equals 67.5 units squared.